We are continuing our look at trigonometric functions, so we are going to continue over the next several weeks to be looking at sine, cosine, tangent, and their buddies. All right, now what we're looking at today, we spent a lot of time in the past few days looking at what happens when our angles are between 0 and 90. But guess what? Not all angles are between 0 and 90. So what we're going to spend some time doing in the next few days is looking at how we deal with situations when our angles are not between 0 and 90. Okay, so what we need to realize is that we have to first of all figure out how we are going to draw these angles that are larger than 90 degrees. Okay, so first of all we got to figure out where we're going to start. The initial side is the fixed side of the angle. The fixed side of the angle. It is where we are going to begin. It is always the positive x-axis. So from 0, 0 to the right is our initial side. It's the ray that we start at. The positive x-axis. This is our initial side. All right. Now, our angle then is going to have a terminal side. And our terminal side is the rotating side of the angle. It is the side, it is the ray that changes what our measurement of that angle will be. It is where our angle ends. Okay, now something important to think about. Something important to think about. If we are moving in a positive direction, our angle is going to open up going counterclockwise against the clock. So we're starting here, which we should realize, it should make sense to us, that this is going to be 0 degrees. Where we start is going to be 0 degrees. If I go in a positive direction, I'm going to rotate around this direction. This is a positive angle. And my terminal side is the ray where that angle is going to end. Okay, so this is my terminal side. It's where that angle is going to end. Now, that green one, I could, move it. I could move it in all directions. I could end it here, I could end it here, I could end it way down there. I could keep spinning it in all directions. That terminal side is our moving side, our moving ray. Okay, in standard position. In standard position and angle, first of all, every time the vertex will be at the origin. The vertex of all of these angles is going to be at 0, 0. Second thing is we have to make sure that our initial side is the positive x-axis. These two things always have to happen so that our angles, so that we are talking about the same angles. All right. Now, as we open up in a positive direction, just a question. If I go from here to here, how far did I go? If my terminal side would end here, how far did I go? 90 degrees. If I continue to go around until here, how far did I go? 180 degrees. If I continue down to here, how far did I go? 270 degrees. And if I get all of the way around back to where I started, where am I at? 360 degrees. Beautiful. So 0 degrees is also the same as 360 degrees. One complete rotation. All right. Now, hopefully we remember from our past experiences working with these angles. If I am looking at the quadrants, does anybody remember when we break this graph into 4 different sections, how we name them? Okay, where is quadrant 1? Upper right-hand corner. And remember how we write them? Yes, beautiful. Your algebra teacher did a fantastic job. Quadrant 1 written with Roman numerals in the upper right-hand corner. Now, where's 2? Upper left, absolutely. Your algebra teachers are fantastic. All right, quadrant 2, upper left. Where's 3? Below it, absolutely. So we have quadrant 3 here. And once again, always writing them with Roman numerals. And that leaves, last but not least, quadrant 4, IV, down in the lower right. Now, as we were commenting before, if I want to have a positive angle, I'm going to go counterclockwise. I'm going to rotate to get a positive angle if I rotate counterclockwise. But if I want a negative angle, that means I'm going to start here and I'm going to go down for a negative angle. So for a negative angle, I would have to rotate clockwise. And I always think, when I think I start here and if I go up, that's positive. If I start here and I go initially up, that's positive. If I start here and I go initially down, that makes me think of negative. That's the way that I separate them and I don't get them mixed up because it is easy to get them confused. Are we okay with that? Questions so far? Just a little bit of background. All right, so in example number 1 here, we're going to be drawing an angle with the given measure in standard position. Tell the quadrant in which the terminal side lies. Okay, so they give me an angle of 105 degrees. Now, first of all, where is my initial side? Positive x-axis, so from 0, 0 to the right, that's where this is going to start. Okay, now from there, if I'm moving 105 degrees, am I going to move up or down? Up. Okay, so let's think about this. If I go from here to here, how far did I go? 90, and then I want to make sure that I go what? 105. So am I gonna make it to the next one? No, I'm gonna go about 15 more. So my terminal side's gonna be right here. And this is 105 degrees. All right, what quadrant am I in there, Alexis? What quadrant am I in here? Quadrant 2, absolutely. So what quadrant does it lie in? It lies in quadrant 2. What? I know. It's hard for me to keep them apart. All right, how about B? Looking at B here, I am now going to be looking at an angle that is negative 120 degrees. So we should know that the positive x-axis is where I start. And if my angle's negative 120 degrees, Kendall, which direction am I going to start moving? What? Absolutely, clockwise. Now if I go to here, how far did I go, Kendall? Negative 90. Am I going to get over to here? Nope. I'm just going to go 30 past that. And here's my angle of negative 120 degrees. All right. What quadrant am I in, Hunter? Yep. Absolutely. Quadrant 3. Quadrant 1, 2, 3, and 4. So this is quadrant 3. All right. 400 degrees. 400 degrees. Okay, I'm starting at the positive x-axis. There's 0. That's my starting point, the positive x-axis. If I'm going 400 degrees, Macy, which direction am I going to move? Yep, I'm going to go counterclockwise. Am I going to make it to here? Yeah. Okay, which takes me to 90. Am I going to go to the next one? Yeah. Which takes me to 180. Am I going to the next one? Yep, that takes me to 270. Am I going to get to the next one? Yes. Yep, that takes me to 360. And then you're going to probably go a little more. I'm going to go some more. Am I going to get to the next one? No, because the next one would be how much? 90. Well, wait, where was I at here?
You was at 360.
I was at 360, and this would be 90, right? So 90 added on to 360 would be 450. And I'm not gonna get to 450, I'm just gonna get to 400. So here I am, and this is my angle of 400 degrees. Tyler, what quadrant is this in? Beautiful. All right. How about negative 640? I know that I'm always starting with this positive x-axis. And if I'm moving negative 640, Taylor, how am I going to start this out? What direction am I moving in? Clockwise. Very nice. All right, Taylor, am I going to get to here? Am I going to get to here? Am I going to get to here? All right, where am I when I'm right here? Negative 270. So am I going to get back to here? Yep. What am I at now? Negative 360. Do I get to the next one? Yep. What am I at now? Can somebody help us out? What am I at right now? Negative 450. So am I going to get to the next one? Yeah. Okay. What am I at now? Negative 540. Am I going to get to the next one? Okay. And if I do, what am I at? 630. Negative 630. Am I going to get to the next one? No. I'm just going to go another 10. And here I am. All right. What quadrant am I in, Casey? Quadrant 1. Very nice. Now I got a question for you. These last two are a little bit interesting. In C, I went 400. It really would have been a whole lot easier if I just would have went how much? 40, right? Because I went 360 and then another 40. 40 would have got me to the exact same place as 400 did. Now in this case, it would have been a whole lot easier if I just went what? 80. Because 80 up would be the same as going 10 past this one after I spun around one full time and almost the second time. So the fact that this angle 400 is really the same as 40 would have been, and this angle negative 640 is really the same as 80 would have been, they have a special relationship. Those angles have a special relationship. What we call them is coterminal angles. We call them coterminal angles. And coterminal angles are angles that end in the same location. End in the same location. So for example, let's look at negative 30 degrees. Negative 30 degrees. If I put this on my coordinate plane here, what would I do to go negative 30 degrees? I'd start here at the positive x-axis, and what would I do? Which way am I moving? I'd go clockwise. I'd go down 30. Am I going to get to here? No. I'm going to go down 30 degrees. This is negative 30 degrees, which takes me to right here. But I got a question. I could have went how much? 300? 330, right? Because a full circle is how many degrees? A full circle is 360 degrees. So if I would have went this way around, I could have went 330 degrees. So negative 30 and 330 degrees are what we call coterminal angles. They're going to get me to the same spot, the same location on my graph. So all of this is built off of the fact that we know that one full circle is how much? 360. Okay, so let's take a look at this then. Find one positive and one negative angle that are coterminal with the angle given. Okay, I start at negative 100. Let's draw a picture of this. I start at negative 100. Well, where is negative 100? Where is negative 100? Yeah, which direction? I'm going to go down 90 and then I'm going to go 10 more, right? This is negative 100 degrees. Now, that's going to take me to exactly the same spot as what? Very nice. If I would have went 260 this direction, it would have taken me the same spot. Anybody have an idea on how we could get that? What did I really do? If I started with negative 100, how did I get the 260? Yeah, I added, or 360, right? Negative 100 plus a full circle of 360 is 260. So negative 100 plus 360 means that 260 degrees is the same angle. Now, if I add 360, what else could I do? I could subtract 360 if I go in the other direction. Absolutely. So negative 100 subtract 360 gives me what? Negative 460, which would get me to exactly the same spot as well. Okay. All right, let's take a look at B. All right, in B we have 575 degrees. Let's figure out where that takes me. 575 degrees. So here I'm starting here. Where is 575 going to take me? One full time around, because that would be 360. All right, then I have to go an extra how much? I went around and it was 360, and then I'm going to go an extra how much? Okay, how did you get that, Alex? Okay, so 575 subtract my full circle of 360, he says is 215 degrees. Now 215 degrees, what quadrant is that going to take me to? 3. Yep, I go 90, I go 180, and then I go some more to get down here to 215 degrees. Now I got a question. I need a negative angle. I need a negative angle as well. Well, what negative angle is going to get me to that same spot?
Good at 360.
What? Karina, what did you say? All right, if I would have started here and I would have went this, I could have went negative 145. Now, Karina, how did you get that negative 145? Okay, and then I knew it was negative, right? So really you took 215 and you subtracted 360 to get negative 145. So I got a question. Really, to find the coterminal angles, what did we do in every case? We either subtracted 360 or we added 360. We're putting one more revolution, one more full circle to get to that angle. Does that make sense? So let's think about what we could do in negative 215 without having to draw my picture. If I know that my angle is negative 215, what could I do to find another angle that is coterminal with that? All right, we can subtract 360. All right, what's negative 215 subtracting 360? What is it? Negative 575. Okay, I got a negative one, but they also want a positive one. How am I going to get a number that ends up to be positive? I've got to add the 360. So what's negative 215? Add 360. $145 degrees. Does that make sense? When I add 360, that means I'm going one full direction around my circle this way, clockwise. And if I subtract when I subtract 360, that means I am going one revolution clockwise. When I add 360, I'm going one complete revolution counterclockwise. Okay. All right. What about 340? 340. If I start with 340, tell me what to do to find a coterminal angle with that. All right, I could subtract 360. Absolutely. I'm going to go one direction clockwise. When I subtract 360, where am I at? Negative 20. Nice. Now, what's another way to get another positive one? What happens if I go the other direction? If I go in a counterclockwise direction, what am I going to do? Add 360, absolutely, 340, and we're going to add 360. What does that get me? 700 degrees. Do you want to see that on the picture? Okay, let's take a look at that on the picture. Okay, so if I draw myself a little sketch, all right, I'm starting right here on the positive x-axis. Where does 340 degrees take me?
For B, I noticed in B you took the sum of 575 minus 360, you added it to 215 minus 360. Why didn't you do the same for 340?
Because 575 is a very special angle. 575 is already bigger than 360. So that means, I mean, I have to get it negative, I have to take 2 complete circles off.
So if the angle's bigger than 360, you gotta take this.
You're going to subtract twice. That's exactly right. All right. So where does 340 take me? Where does 340 take me? What quadrant am I in? The 4th. Yep. I go 90, I go 180, I go 270, and then I go some more over here. This is 340 degrees. Now, what's the same way I could have gotten there? Negative 20. I could have went down 20 degrees. Or I could have said, okay, I got to 340, but now I'm not done spinning yet. I'm not done spinning yet. I want to go one more full circle around, which means I'm going to do the 340, and I'm going to add one more circle, which is 360, which is how I got that 700 degrees. Does it help with the picture? Draw yourself a sketch. Okay, now, looking at how this relates to sine, cosine, tangent, and their buddies. Okay? When I am looking at my angles, and notice that they drew my angle here in the the second quadrant. Okay? Now, what we're going to do is they're going to give us a point out here on this side, the point X and Y. The point X and Y. Okay? And if I were to draw a circle through that point, my circle might look something like this, correct? And that circle would have a radius of r. Okay? A lot of trigonometry, most of trigonometry is based on triangles. Okay? So, to help us with that triangle work, we're going to build a triangle from this point. Okay? To get to this point, think about how you plotted this point, X and Y. I went to the left so far, and then I went up so far. Well, when I went to the left so far and up so far, I really built a little right triangle. I went to the left, my number X, and I went up my number Y. And I built myself a nice little right triangle. Now, when I built that little right triangle, I made an angle here. And we're going to call that angle, that is our angle theta. Actually, we're going to call that our angle theta prime. Theta prime is our helper angle. Because really, my angle started all the way over here and went over to here. That is our angle theta. But this little angle theta here is our helper angle. He helps us in this triangle. Okay, now, let's go back to our trig functions. What are the 3 big ones? What are our 3 trig functions? Sine, cosine, and tangent. Okay? Sine, cosine, and tangent. All right, now, think about this. How do we find sine? Opposite over hypotenuse. Okay? We're in this triangle. We're here with our little theta prime, our fancy theta.
Miss, what's the R representing again?
What?
The R.
The R is the radius of the circle that I would be if I use that point and I made a circle. Okay? Now, if I'm looking at this little theta prime here, what is opposite of that angle theta? Y. Over what's my hypotenuse? The radius, R. Okay? How do I find cosine? Adjacent over hypotenuse. Okay? Now, if I look at this angle, what is adjacent to this angle of theta? X over what's my hypotenuse? R. And tangent. How do I find tangent? Opposite over adjacent. Okay? So as I look at this, what is opposite of this angle theta? Y over what's adjacent? X. All right, now, who are their buddies? Who's buddies with sine? Cosecant. All right, so cosecant of theta. Now, if sine ends up to be y over r, what is cosecant going to end up to be? R over y. All right, who's buddies with cosine? Secant. Okay, so if cosine is x over r, what is secant going to end up to be? R over x. And last but not least, if tangent is y over x, who's buddies with tangent? Cotangent, and what is he going to be? X over y. Okay, now I want to show you what these look like in all of your quadrants. Okay, I want to show you what these look like in all of your quadrants. If I have a point in the first quadrant, okay, so in other words, if I draw an angle in the first quadrant, it's going to look like this. Okay, if I draw an angle in the second quadrant, we know it's going to look like this. If I draw an angle in the third quadrant, we know it's going to look like this. And if I draw an angle in the fourth quadrant, we know it's going to look like this. What? All right. Now, I'm going to pick a point on these sides. So we'll have a point here that we're going to call x and y. We're going to have a point here that we're going to call x and y. We're going to have a point on this side that we're going to call x and y. We're going to have a point on this side that we're going to call x and y. Okay, now, backing up. How do I get to this point xy? How do I graph that point? How do I graph this point xy? How do I get there on my graph? If I were going to graph that point is, let's say, 5, 7. How do I get there? Right 5, up 7. So that means I go to the right x and I go up y. Okay? And what do we call this distance from 0, 0 to our point? R. All right. Now, let's take a look here. How do I get to this point, xy? I go to the left x, and I go up y. And we know that this is the radius of that circle if I drew a circle through it. But I got a question for you. When I go to the left x, what kind of number is that going to be? It's going to be a negative. Okay, and that's important. That's going to be very, very important.
So x is over the face.
What?
X is over the face.
X is always our movement on the x-axis, just like when we're graphing our points. Yep, absolutely. Okay, let's come over here. How do I get to this xy? Well, I move to the left x, and then I go down y. Okay? Now, when I move to the left x, what kind of number is that going to be? It's going to be negative. When I move down y, what kind of number is that going to be? It's going to be a negative. And this is the radius of that circle. And our radius is always going to be what kind of number? Positive. A radius of a circle is always positive. Okay, over here. How do I get to this last point? If I'm graphing to the fourth quadrant, how do I get to this last point? I'm going to go to the right x and then down y. I'm going to go to the right x and then down y. Now, are any of those numbers going to be negative? Yeah, the y, I'm going to go right x, that's positive x, and down y, so that's going to be a negative y. And the radius of that circle is still going to be positive. Okay, so we need to remember, one little note we've got to make to ourselves. The r is always positive. The x and the y can be negative or positive. The x and the y can be negative or positive. Now, you should be asking, well, what am I going to do with this? What am I going to possibly do with this? Why do I care? And that's what we're getting to in a second. All right, got that all written down? All right, let's flip over and see what we're going to do with that. Okay, so let -4, -3 be a point on the terminal side of theta. Okay, well, evaluate sine, cosine, and tangent. Okay, all right. So I need to figure out where I'm at. I want to draw a picture. I want to draw a picture. Okay, so I'm going to make myself a little sketch. All right, and I know that the initial side of this angle is the positive x-axis. All right, now where is -4, -3? I'm going to go left 4 and down 3. I'm going to go left 4 and down 3. Here is -4, -3, and that is my other ray of this angle. Everybody with me so far? Okay, now I've got to build my triangle. I've got to build my triangle, and the way that I build my triangle is, how did I get to that point? Well, how did I get to this point? I moved left 4. What am I going to call that side? Yep. What is it, though? -4. And then I went down 3, and what am I going to call this side? -3. And I created a right triangle. Now, what other piece do I need to know in this triangle? R. I need to know this R. Anybody have a thought on what we can do to find R? Yeah, which theorem? Pythagorean theorem. You bet. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Okay, which one's our C? R. Okay, so R squared is equal to, well, I've got -4 squared plus -3 squared is equal to R squared. -4 times -4 is 16, plus -3 times -3 is 9 is equal to R squared. All right, so what do I get for R squared? All right, R squared is 25, so what's R? Square root of both sides, R is 5. All right, so this side is 5. Okay, now remember, where is my angle? Where is my angle? My angle is always the one that's attached to 0, 0. Okay? So my angle theta is the angle that has a vertex at 0, 0. Okay, now I want to find the sine, the cosine, and the tangent. All right, how do I find sine? Opposite over hypotenuse. Beautiful. All right, so what is opposite of this angle theta? -3. Over what's the hypotenuse? 5. So sine right there is -3/5. All right, how do I find cosine? Adjacent over hypotenuse. All right, what is adjacent to that angle theta? What is adjacent to that angle theta? -4 over, what's the hypotenuse? 5. And how do I find tangent? Opposite over adjacent. Fantastic. All right, what's opposite of that angle theta? -3 over, what's adjacent? -4. Well, what's -3 over -4? Beautiful. A negative divided by a negative is positive, so that simplifies to positive 3/4. Questions? Got to draw that picture. Got to do a good job of drawing the picture.